Okay, so this is video 75, and we just got cut off from before. This is where we left off. So like I was saying, if we have our basic graph, and that right there is going to be our u, is going to be a function of q1 comma q2. Yeah, but this is always going to be q2, our two-dimensional graph, which is our contour line, which is our indifference curve, is always going to be q2 as a function of q1. Okay, so assuming we have that graph, I was just saying that we have the MRS, it's going to say x comma y, yeah, is always going to equal, it is always going to equal, I don't want to write all of that, but it's the partial derivative of 1 divided by the partial derivative of 2. So remember, it's going to be upside down in accordance with the slope. If it's 2 over 1, it's going to be the partial with respect to 1 divided by the partial with respect to 2, which does mean this. All of this is positive so far. And if all of that is positive, what does that mean? It means it's negative the actual slope, which is kind of abbreviated this way. The slope is abbreviated, remember, with respect to the graph. All slopes that exist is going to be y over x, or rise over run. And just remember, if there's a 1 here, there's a 2 here, and if there's a 2 there, then there's a 1 over there. But the derivatives and the actual slope are upside down notations to each other by the theory that we derived in chapter 2, which is why they say that. Okay, so that's the basic thing. There might be 1 or 2 little things in there that I missed, but uh, we said what that was the last time there. Marginal rate of substitution. I shouldn't forget these things. It's very obvious. Marginal rate of substitution is going to be the partial divided by the partial. Is everything is positive, so all of it is going to be negative. The slope, or the negative for Cobb-Douglas, is always negative. The slope for Cobb-Douglas always negative. Slope for the linear and all that is also always negative. But we can kind of read the little paragraph, but that's basically what it is there. So everything in here we just said, we can kind of read through. I don't mean to skip all of it, but we want to kind of show it in pieces. Yeah, so we're just kind of illustrating the paragraphs. It's paragraph 2. So we don't really need to write this. We can. It is the same either way. It's exactly the same. So we see Q2 as a function of Q1, which is how it always is. It's no different if we do Q1 as a function of Q2, no difference there. So on the left, it is by convention MRS 1 comma 2. If we chose on the right, we would technically want to say MRS 2 comma 1. It's just notation, not our math. But if we didn't say that, technically our notation would be wrong. But everything is just the opposite. So before we said we have to have the marginal is the same as the partial derivative. We said that we have to have the marginal of the x divided by the marginal of the y. This is for him, is going to equal negative the slope, which is of course always y. Yeah, so everything is literally just flipped for this one. This would be marginal u2 over marginal u1 equals negative delta q1 over delta q2. So they are the exact same thing, just the convention is flipped. So if we erase anything too quick, we can always just go back in the video. But that has nothing to do with math. All of that is literally just the convention or the notation thing. Okay, so it says all that, and they might give us like an example buried in there. The math is too easy, and it's just review. That right there is exactly what we just said. For the most part, that's just giving us an example there. I don't think it's important to read all of that. Okay, we go back up to where it says 4.4. I'm not going to fly through that, but very good. Like I said, the first 10 pages are literally all review. It's all they're going to be. So we have the same, it'll say it in there, diminishing marginal rate of substitution. Sometimes I do say it wrong. There's more than one way to say it and all that. But let's kind of go back up here. They're just, right when we get here, yeah, there's no new terminology there when it says 4.4a. We can go down to the graphs. Okay, so we kind of took a quick look at that. Okay, so I just want to go back up. I didn't mean to skip it, but we're just showing the three examples. The Cobb-Douglas, they always have two different words for the same thing, but it is Cobb-Douglas is automatically going to be the DMRS. That means the slope is always technically negative everywhere. Diminishing marginal rate of substitution. Hopefully I don't mess up saying it. But DMRS is always Cobb-Douglas, and Cobb-Douglas is always DMRS. They go hand in hand, yeah. And then we have, like I said, two different terminologies that are the same. We have the one that's always linear, conceptually is going to be called perfect substitutes. And then we have the one that is L-shaped, or things that have to be in certain proportions, is always going to be called perfect complements, which is just another name for saying a specific proportion. Yeah. So it is chapter 4, and all those concepts are exactly the same as chapter 3. In other words, each one of these for the three concepts are U. Those are our utility graphs. And we're always going to have, they're going to define all this right now, but we're always going to have let's try and do it right there. The budget line is what's coming next. My line is not very well, just looks very bad how I did it, but my budget line goes through their graph right there. And what the budget line can be steeper, the budget line can be gentler, the budget line can be, it's going to be those same three. It's always the 3 for that case, which is less than, greater than, or equal to. And then for the perfect complements, it's just kind of silly. We know that the budget line has to be on the kink. Yeah, so they're going to go through all of that theory right now. So those are our 3 cases. Chapter 3, it was isocosts. For chapter 4, it's going to be indifference curves and the budget line. The graphs are exactly the same as the obvious point that we're making. So here they literally describe all the same stuff. I'm flying through this, but they're describing all the same stuff from chapter 3. We can kind of pause really quick and take a read if we want. I don't always remember everything they're talking about. Yeah, perfect complements is the 3rd, but they're just talking about all that. Yeah. And then figure 4.5 does a comparison between the 3, where it says blue, red, black. Okay, so they're just comparing the 3 right there. Yeah. Okay, so we'll continue in the next video. We discussed what? That was basically indifference curves continued. I know that always getting ahead of myself. Been talking about the budget line, but now the book actually introduces the budget line in the next video.